Hari Om. Now in this video we are discussing an important idea of the representation of alternating current and voltages flowing through instruments like resistor, inductor and capacitor. Now as you come across the flow phase through resistance and inductor and capacitor, you can find that this voltage and current will not be always flowing in phase. Sometimes the current will be lagging, or in some case current will be leading. So there will be a phase angle difference between the instantaneous values of current and voltage when it flows through a electrical element. Basically we consider three elements: one resistor, inductor and capacitor. So when it comes like that, then mathematical application of identifying those situations becomes difficult when we come across the combination of these elements together. Individually, no problem. When you take the combination circuits like capacitor and resistor, capacitor and inductor, capacitor and inductor and resistor, and like that, or all these three together, then the analyzing of the circuit becomes very difficult. There we use a new technique or new idea of rotating vector, and that rotating vector we call it as phasors. And the diagram drawn using this rotating vector we call it as phasor diagram. So what is actually a phasor diagram means? It is a diagram that represents the variation of or the flow of instantaneous values of alternating current and voltage along with the phase angle difference. Okay? But we know that current and voltage are basically scalar quantities. Current and voltages are basically scalar quantities. Then how we can represent that using a vector? It's because this current and voltage are found to be varying harmonically. There is a definite time period and definite frequency are coming. And therefore, we can use this rotating vectors to represent the instantaneous values of the current and voltage as we do in the case of what you call vector addition. Okay, so phasor diagrams is actually drawn like this, 4 quadrants, and this 4 quadrants represents the complete cycle of an AC. That means an AC when it flows in the form like this, okay, this variation can be represented here by the rotating vector, okay, taking the projection of the rotating vector in the form of a circle, and if the value is actually here, then this will be omega t angle, suppose. In the first quadrant it comes. So this comes as the first quadrant, this is second, and this is third, and this is fourth. First, second, third and fourth quadrants. First quadrant, second quadrant, third and fourth. So if I am representing the value here, then this is omega t, then this will be the value of I or B at that particular instant. So this projection over here gives the value of I. Then what is this value? This is nothing but the peak value of current. So this is IM. So taking like this, we can represent this IA as I equal to IM sin omega t. Yes, the projection I, we can write it as, what is now what here? This is omega t, this is also omega t. So this comes as the opposite side of this one. So it is IM sin omega t. Or you can take the resolving effect and also you can say I equal to IM sin omega t. So if the letter is on this side, then that is coming over here, the second quadrant. If you are taking the letter over here, it comes over here, and the projection will be here. So when it comes to this particular point, you will be getting the peak value that is here. So like this, you can represent the instantaneous values of what we call the alternating current and voltage using a phasor diagram. Okay.